Good morning, everyone. My name is Chris Vantine, Chief Technologist for the Western region at Red Hat. And I've been with Red Hat for about 11 years, working with strategic partners and customers who are adopting Red Hat's emerging technologies. Certainly, Red Hat is known for Linux, but we've moved into many other areas such as middleware, virtualization, software-defined storage, cloud management, and container management. And one of the hot topics around some of these technologies is certainly DevOps. Our customers are typically asking us, questions like how can we enable developers to be more productive and have access to the tools and the platforms that they need. Also, how can we enable operations to be more efficient and reduce costs? But ultimately, how can we enable the business to deliver a product faster and sooner? And so in today's talk, I'm going to talk about some of the enabling technologies for DevOps from the infrastructure perspective, as well as the developer. And then also talk about some of the business drivers for DevOps. Feel free to ask questions as we go. So starting out with the business motivators, this is a quote found in the CNBC site. 40% of the Fortune 500 on S&P will not exist in 10 years. Right? This is a study that was done. And what is driving that? Why would that actually happen? I think Mark Andreessen really nailed it on the head when he talked about how software is eating the world. And I'm sure many of us have seen this happening in different industries. Let's take a look at one. Does anybody recognize what this is a photo of? Right, this is a Tesla automobile factory assembly line full of robotics and certainly software automating the production of these vehicles. But the reason I show this isn't just because the robotics in the assembly line, but the software that's actually in these vehicles, millions of lines of code. And for the first time, you can actually go to a dealer's lot and drive off that lot knowing that your car will actually get better in 6, 12, 18 months down the road.
Or worse.
In software, if it does get worse, right, they can deliver a software update over the wire versus a physical recall. Sure. And they could save millions of dollars. And so that is a fundamental difference in the industry. Not only that.
Worse when you have a cell phone and they want to push you to a new phone, so they put out a shitty update.
You can disable updates if you like. It's up to the user. So it's not forced on you in many different cases. At Red Hat, we don't force updates on our customers. They can actually just apply them as they go. Or you can have automated updates. So a lot of different options. Also, software is changing things like the performance of the vehicle. It can improve the 0 to 60 time. Or it can improve the applications in the car. And so there's a fundamental difference driving the industry. And it's not just the automobile industry, many other industries. Take a look at an industry that rested on its laurels, San Francisco taxi industry. I used to live in San Francisco, and the taxis there really are suffering because several years ago they were averaging almost 1,500 rides a month. Since plummeted, this is a little bit of old data, but a couple Augusts ago, just over 500 rides a month now. Declined by 65%. And so this coincides with the introduction of Uber and Lyft into the marketplace. And their mobile application fundamentally changed the user experience. Right? I no longer had to wonder when I had to catch an 8 a.m. flight whether I was going to make it or not, because I didn't know if the cab was going to show up. And so I ultimately had to get in the car and drive to the airport. Also, when I get into an unknown city, I didn't know if the cab was going the long way or the wrong way. With this app, they now have automated turn-by-turn directions. And when I got to the destination, I didn't have to wonder what excuse would it be this time of why the taxi driver doesn't take a credit card. The machine's broken, etc. And so with the Uber or Lyft app, it automatically deducts from my electronic account. And so not only are software and these mobile applications fundamentally changing the user experience, but also rapidly enabling them to introduce new products and services. Down in Los Angeles, where I now reside, they're able to introduce things like deliver lunch via the Uber app, or to have a special event package to get to a festival or another city. and try these out, and if they work, that's great. They can continue and expand on that. But if not, they can quickly move and turn to a different direction. And so, IT is at an inflection point. Gartner calls this the shift from mode 1 to mode 2, really a shift in the how, what, and where of application development process, application architecture, and the underlying infrastructure. A shift away from the waterfall model, which was used back in the day, maybe a release every year or 2 years to your software application, to a shift of every 2 weeks having an update, enabling DevOps, allowing you to produce software much quicker, and then also packaging or architecting that software application in microservices rather than this huge monolithic application. And then delivering that software, not just to physical or virtual servers, but packaging it in containers, allowing you to deploy once, or package once and deploy anywhere, whether it's physical, virtual, public, or private infrastructure. And the promise is that this will ultimately enable the business to deliver the products faster and sooner with higher quality. And as the businesses rely more on software, it has its own set of challenges because software projects are typically over budget, delayed, and don't achieve the full value because ultimately they either strip features to meet the deadline, or by the time it's delivered, it kind of missed its window of opportunity. And so there's some fundamental challenges with software delivery. And so in the typical organization today, you have walled off, siloed organizations. Right? You have your development team, your testing team or QA, and you have operations. They're all typically using their own set of tools, they're using their own processes, and they're doing their own work, whether it's building the server, configuring the server, and that doesn't make any sense. And so as a result, you typically have the developers chucking over their code to QA. They build out their infrastructure in their own environment. Maybe they're using different tools, so it's hard to collaborate and communicate, and it's just slow. Likewise, when it gets into production, they have to repeat what was already done in development and QA in terms of building out environments, and the production environment doesn't look anything like the development environment. And so issues are encountered for the first time in production when they could have been captured early on in the process, and as a result, software quality suffers. And so this has led, with the rise of cloud and mobile applications to an evolving development process, a move away from waterfall to agile. And with agile, you have frequent releases, short development cycles, but the challenge with this is that the developers spend more time on deployment, and that doesn't make any sense because they're using the same deployment processes. Ideally, you want your developers developing not infrastructure code to automate a pipeline, but business logic that changes the business. And then likewise, you want your testers testing, and then the operations folks doing root cause analysis and troubleshooting issues. And so what can IT do? Turning to DevOps, right? DevOps is a fundamental shift in the software development method, stresses communication with IT and the developers, but applies many of the principles of Agile, but to the full life cycle of the application, from dev, test, into production. And so let's take a look, how to do this. First off, it's a real cultural shift. One is, organizationally bringing these teams together, the developers, your testers, and your operations folks, and getting them collaborating, getting them speaking the same language, using the same tooling, making it much more efficient and collaborative in the organization. Also, some fundamental enablers are configuration and code, right? Why is the development environment using a source code repository having version control for this application, yet the infrastructure is maybe manually built or not reproducible? And so turning that into code, having standardized environments, by giving the developers access to a production-like environment early in the process, so issues are resolved up front. If you wait longer and longer, the technical debt gets that much higher to resolve these. Linux containers provide the ability to package your software once and then deploy it anywhere. Right? Take that artifact from development, put it into test, put it into production as is. Also, automated provisioning. Right? The days of manually building servers, software stacks and configuring them is over. And so using automation so that you can quickly recover and quickly build out environments. And a key concept around DevOps is to be able to fail fast and recover versus never fail. Fundamentally very different in how you approach architecting your infrastructure, but also the processes around that. And so automation is a key aspect. Secondly, continuous integration and continuous deployment. Continuous integration is all about catching issues early in the cycle, encouraging developers to check in, having pull requests so you can review the code by your peers, and then quickly running that through an integration testing process that's automated, being able to build your artifacts and then be able to continuously deploy them into the environment as the business needs it. And another key concept around DevOps is small changes equal less risk. So this move towards microservices allows you to kind of package your application in a much smaller and architecturally fundamental model versus a monolithic, and making it much easier to actually deploy that into production and reduce the risk that actual change would have in production. We'll take a look at some of these statistics as well. Thirdly, what enables DevOps? Continuous innovation. So enabling your developers the freedom to innovate and removing the bottlenecks and the roadblocks to doing that. Typically, a lot of customers talk to, their developers don't have access to the tools that they need, and this is evident just with the rise of shadow IT over the past several years. Right? Why is that happening? Because IT is not delivering what the developers need. And so IT needs to provide developer self-service so that they have access to the tools and platforms they need, and enabling those developers to rapidly prototype what they need to do. And so
shadow IT, by the way.
Shadow IT is when a customer of IT in your organization, maybe the business unit or developers, they go around IT and create their own IT environment.
Nice.
So typically maybe they go to a public cloud or they build out their own infrastructure. We at Red Hat even have had that internally from time to time because the business or the engineering group is moving faster than what IT is.
Gotcha.
So a key concept here is cultural change. Acceptance of failure. Fundamental shift here. It's okay to fail. And the reason it's okay to fail is that IT is automated and provide the ability to recover quickly from issues. And your infrastructure has been designed for failure. So what organizations have successfully used DevOps? There's several examples. You have LinkedIn. They moved from a release once a month to several times a day. They also, maybe Etsy is another example of DevOps. They have the ability to do dozens of updates a day. And it's not just about how many updates you can do per day. It's being able to deliver an update when the business needs it. Right? And that's how IT changes from a cost center to being a strategic differentiator for the organization. And so another example here is Amazon Web Services. Right? They have the ability to do 10,000 updates an hour. You're like, wow, if they do updates at that scale, there must be a lot of outages caused by these updates. And their stats show that only 0.001% of outages are due to updates. And so if you're out in the audience wondering, how can we go into our organization and apply DevOps? Well, there's really three things to be thinking about. One is how to quickly, reliably deliver these capabilities. Two is what kinds of new apps and services to deliver and support. And then where to run these new apps and services. And so it's not just DevOps, the process or the culture, that's the how, but also the what in terms of the microservices or developing cloud applications. And then thirdly, deploying those applications on your cloud infrastructure, maybe within containers as well. And so that's how you would get an optimal environment and being able to take full advantage of this new process, the new architecture, and in a new infrastructure. Many organizations, maybe they build out an OpenStack cloud, right? But they're using monolithic development architecture, and they're using waterfall processes. They're not taking full advantage of that infrastructure. Right? They're not taking full advantage of its capabilities to scale up, scale down, and dynamically provision. Likewise, if you adopt DevOps, and your development team's moving fast, has the ability to quickly introduce new change into a production environment. Well, if the infrastructure still takes 6 weeks to provision, it doesn't do much good. And so that's why these three go hand in hand, to be able to be fully optimized. You want to consider all three, although you don't have to implement all three at the same time. So let's talk about some of the technology that can enable this in your organization. So the operating system, of course, is evolving to adopt this model. And the first thing that's going in there, many of you are familiar with Docker, I'm sure already. Well, Linux containers are going into the operating system. At Red Hat, we have a containerized OS called Atomic, which is an upstream project, which incorporates Docker into it. And it's also a very lightweight footprint so that you can optimize the running of containers and take full advantage of the ability to quickly start and stop those container services. Second component is, Docker's great on an individual basis, but what do you do when you want to deploy complicated multiple service applications? Right? You need an orchestrator and a scheduler. And so the orchestrator allows you to define that application, multiple services, and be able to deploy it as a single application to your infrastructure. You may want to use Ansible if you're a developer or in the testing environment, or something like Kubernetes if you're going at scale in a data center. So you fully are able to deploy complex applications which automatically take care of things like networking and utilization efficiencies. Also, a scheduler. So how do you intelligently schedule these containers across a data center or multiple data centers? How do you make sure that you're efficiently using your resources? How do you make sure that applications are being scheduled to the right resources as well? They're optimized for that particular service. And so Kubernetes has a scheduler built in that can be used to intelligently place those, and you can take full advantage of the API as well. And so those are some of the three fundamental shifts in the operating system to enable DevOps as well as containers. And so, containers really enable DevOps as well because they provide a consistent packaging format no matter what language your developers are programming in. So whether it's Java, C, Node.js, Perl, Python, etc., it can be put into a container image. Think of it in the Java world, you put it into an EAR file, for example, right? But that's for Java only typically. And so that's a fundamental shift. And then likewise, in the Java world, you run on a JVM. In a container world, you run on the runtime, the Docker runtime, for example. And the container image will pull in all the dependencies that are necessary so that that image can then be transferred from physical to virtual, dev to test, as is, without having to be rebuilt as well. You'll be able to run on the underlying infrastructure.
What do you use to form the configuration stuff? Because you don't have to config in the container.
Sure, so we're going to talk about the different components. So essentially Docker is about a build, ship, and run model to enable DevOps. The build phase is you have a Docker file. Think of a Docker file similar to like a make file if you're building like a C application. It defines exactly how to build it. In this Docker file, it's saying, hey, use Fedora, and then echo the hello. And so very simple. And what that'll do is actually, when you build it, pull down Fedora from your repository that is sitting in the back end and create an image file. And that image file can then be shipped and stored into a registry, whether it's a private or public registry, then therefore making it available to whatever environment you want to put it in, as is, or other users as well. And so I can then push that image into a shared repository and then pull it down to whatever environment, and then because there's standardization at the runtime across my environment with Docker runtime, I can then pull that image and create a container instance based on the container image. So I can have multiple instances of that image, and that can be run on any environment. Right? So that's kind of like the Java JVM allows you to run Java wherever it's installed as well. So a lot of parallels with Java, but it's for any language. And so Docker's great, on an individual workstation basis, but the challenge is how do you effectively deploy across the data center? And so that's where Kubernetes, the container cluster management software providing scheduling and orchestration of containers, comes into play. Kubernetes was founded by Google based on their long history and use of containers internally. They deploy billions of containers every week. And so they've taken that expertise, and they've had multiple generations of orchestration and scheduling software for containers, and have open sourced that into the Kubernetes community. So Red Hat is a leading participator along with Google for that project, and many others in the industry are actively contributing to the project. And so let's take a look at how Kubernetes enables DevOps. So first off, it allows you to simply deploy an application. We're going to take a look at the GUI view. There's also a command line. In this example, I'm going to pull in a JSON file, which actually defines this particular application into a front end and a back end service. And I'm going to go ahead and deploy that application. And so it'll actually schedule the application and go out into my cluster of machines and find a resource that's available to create the front end and back end instance of a container image. And so here I can actually see the images deployed and created as an instance. So I have my database, and then I have my front end as well. And I have one instance for each of those. But I may want to scale the front end because there's more load. And so I'm going to manually scale it using the GUI and increase this instances up to 10 from 1. And so Kubernetes will automatically go ahead and replicate that front end service. So I now have 10 front ends and a single back end. So I no longer have to manually go out there and install. Another thing that Kubernetes will do is health check. So now that I have those instances out there and running, I want to make sure that I have that number of instances running at all time. Right? And if something fails, I want it to automatically recover. So Kubernetes will continuously monitor. So in this example, there's 3 instances. And so if there's a failure, in this case, this instance went down, some troubleshoot, or there's some sort of issue. And so Kubernetes automatically detects that, and it'll go ahead and schedule a replacement instance of that to ensure at all times there's 3 instances in this example. So it's declarative. You just find the desired end state, and Kubernetes will make sure that it achieves that. And so here it's repaired it, and it's taken down the failed instance. So no longer am I going to get a 2 a.m. call because my capacity of front-end instances is below 3. Right? I don't have to manually go ahead and rectify that issue. Kubernetes will take care of that automatically for you. So a great thing as a sysadmin. Also, how does it enable DevOps? Well, when you deploy a new application, right, it offers you the ability to do A/B deployments. So you have version 1 out there already, receiving live traffic, and the development team wants to go ahead and test version 1.2, so they can go ahead and deploy that with Kubernetes, test it out in QA, and once it passes QA, they can go ahead and switch over the environment automatically from version 1 to 1.2. It's already deployed. It's a simple changing of the load balancer, and the software load balancer in this case, over to 1.2. Right? I didn't have to wait for Kubernetes to upgrade or deploy this additional app instances because it's already deployed. And so it's an immediate failover or switch over to that new version. So a lot of organizations that I talk to, one of the key challenges is the time it takes at scale to upgrade from one version to another. You know, some organizations say it takes them 30 minutes to go from version 1 to version 1.2. And so this process and capability within Kubernetes will help those organizations greatly reduce that time. And likewise, once that version is out there, you may want to roll back. And so Kubernetes provides you that ability to switch back to that previous version. Now in a DevOps environment, typically what I see customers are doing is they're rolling forward, not rolling back, right? Because if they've really embraced microservices, the change is small, and so the change to fix it is small too. And it's much easier to just roll forward to a newer version than to actually recover and roll back. And so I see a lot of organizations taking that approach in a DevOps environment. So we've talked about Docker, Kubernetes. You know, Docker, good for an individual developer. Kubernetes, great for an IT operations team managing containers at scale. But above and beyond that, what about the developer? How can we abstract the developer from network storage, instances, containers, etc.? And so that's where a PaaS comes into play. Platform as a service sits on top of your infrastructure, and in this case, sitting on top of Docker and Kubernetes to provide automated building of code into containers and automatic deployment of those containers into the infrastructure. So really providing a developer view and workflow for self-provisioning, environment standardization, meaning the developer has access to the tools and platforms they need, key component of DevOps. Also allowing that developer to automatically scale. So we showed you in the Kubernetes model how you were manually scaling. How about automating that based on intelligence of your traffic or your infrastructure? And then also providing centralized management, but more importantly, how do you manage the workflow or the pipeline of your container from dev, QA, user acceptance testing to production? Right? How do you manage that full life cycle? And so that's what a PaaS allows you to manage. Once you build that Docker image, to manage that life cycle and the promotion of that image through a typical life cycle in your environment. And so, you know, a PaaS just shows you Red Hat works in the upstream community called OpenShift Origin. And this gives you a view of what the PaaS looks like. It allows the developer really to log in through a GUI or CLI and to see all the standardized and available development platforms, whether it's application or database. Right? And so they have these pre-selected ones. Any Docker image can be uploaded here, so you can rapidly move and incorporate new versions or new platforms. Right? That's a real bottleneck in most organizations. It's very difficult to bring in new platforms and tools, and so that's another reason for shadow IT, is that IT can't keep up with that demand for the latest technology. Developers just go and invent their own process or use their own processes. So this is a great enabler of incorporating any Docker-based image. And then the PaaS automates the ability of the developer to just push code. And the building of container images is taken care of for them. The updating of container images is taken care of them for them because it uses a base image of the operating system that the operations team has provided. And any time that base image gets updated from a security perspective, it can trigger an automated update of that container for the developer. So they don't have to worry about keeping track of security issues, etc. The PaaS will actually automate the process of rebuilding these images once a security errata is released for any of these images. And then it can actually automatically deploy that updated image out into production. And so this shows you kind of a graphical view of how you can deploy these images, and then you can actually automatically scale the image as well. And so this just provides a dashboard view, which is kind of a high-level abstraction of the Kubernetes dashboard that I showed you earlier. And here, showing you from a developer perspective, you can see a summary of the builds. So here I have build number 3, number 4, 5, 6, etc., and you can see whether they were successful or failed. And so the build in this case, you're taking that source from GitHub, it's building it, doing some continuous integration, producing a Docker image as a result, and that image is then stored in a repository. That image was built on a base image that was standardized, maybe it's RHEL, Fedora, etc., and that was provided by the operations team. So this is how the operations team and the developers can work side by side and together and collaborate for container images, rather than your developers going out and randomly pulling images. You have no idea whether they have security issues, who built those images. You know, how do you become assured that that's safe to deploy in your production environment?
Who built the OpenShift images, or is that?
I'm sorry?
Is OpenShift like a place where you go get images, or is this something that you run locally then?
Sure. So OpenShift is built on top of Docker and Kubernetes and provides a developer layer above that.
Okay.
So it's installed in your infrastructure,
In your
or
organization.
you can use it. There's a public hosted version as well. So you can go to OpenShift Online, which
Gotcha.
allows you to have a hosted version of that. So you have the option internal or external.
Okay, and does it come with pre-built images, like when you
Yes.
do the public one?
Yeah, so this slide here, does it come with predefined images?
Yes.
Yes, so we've loaded some standard images, but you can take any Docker image. So the input to OpenShift could be source code, and we'll build the image for you, because we know how to build a variety of different codes and languages. Or you can just suck in a Docker image as is
Okay, cool.
and take full advantage of the thousands of Docker images already built. So let's take a look at case study. You know, I worked with a customer down in Silicon Valley that was looking to transform their organization, and take a look at some of the challenges that they have, and see if this is typical maybe in some of your environments you've heard about. It could take 6 weeks to get a single word changed on the website. And this is a brand name that we all have heard and probably use on a regular basis. And it took 2 years after a competitive startup launch to get a competing product to market. Okay. And another thing is that they were using a proprietary in-house developed application platform, and so they didn't have access to open standard, open source platforms such as Node.js. Right? They were kind of limited on what they could adopt internally. And it also made recruiting a challenge as well, because they didn't want to learn skills that were unique to that company, because they couldn't go anywhere else with that skill set. And it was hard to attract people into the company as well. So they wanted to embrace open standards. And so this particular company, what they did is they implemented a continuous integration, continuous delivery model. In this case, Jenkins was the solution there. They adjusted the organization and some process, so brought in the developers, testers, and operations folks, and they leveraged a PaaS, which was container-based as well. And so this is what kind of the flow looked like when they moved to this model. And the end result is they were now, instead of 6 weeks to make a word change, they could do it under 30 minutes every single time. And so the way they accomplished this was that the developer would be able to check in source code into their existing GitHub. That would trigger an event, an alert to the Jenkins that was running in the PaaS. And so that triggered a continuous integration. And it would build, the application, they would build it into a container as well. They would put that container into a artifact repo, in this case Nexus. As it got promoted from release to production, in their environment, they still want operations to have full control over the deployment of updates into the production environment. And so they were able to control that. And so the operations folks were pushing binaries, not source code, in the production. In this case, container images. For the first time, they were able to then do partitioning. So they were able to update that application 10%, 20% to the new version, test it out. As they got more comfortable, they would increase the switch over. They also could have multiple versions running in production. So maybe they had APAC on one and EMEA on another, different than the North American version. And then they also, if they wanted to, could do rollback. And it integrated with their existing infrastructure, enabling them to automatically scale up and down, so they didn't have to call their networking engineering team every time they added an app or every time they added or removed capacity. And within Jenkins, they then defined the different phases of their application lifecycle, from commit to acceptance to UAT and production. And they could define either automated progression from phase to phase, or they could have manual movement from one phase to another. And so what this kind of shows you is that the developers could trigger, every time they check in something, an automated pipeline. And so here, 68, there was a failure in commit. They went and updated the code, recommitted it. This time it passed, but now it failed acceptance testing. Right? They went back, fixed it, recommitted. Now it passed UAT, and now it's being pushed into production. Right? So you have a visual view of the flow of every pipeline. And these pipelines are automated. And behind the scenes, what's happening is these container images are being pushed out to different environments behind the scene, and they're being created on demand as well. So I don't have to manually create a testing environment. I don't have to manually create a build environment, etc. If I want to, one of the pipelines I want to do extra load testing, I could do that. It automatically will scale up that application to match that load. Also, another thing that customers do is they built in security into the DevOps flow here. Right, so as you build container images every time, do a security scan of that image as well. So you can check and make sure that what developers are pulling down is not bringing in known security vulnerabilities as well. And so that's easy to put into the workflow as well. And so from an architectural perspective, what does this look like? Well, a lot of environments are not being built from scratch, so key thing is, how do I incorporate this into my existing environment? In this customer, they had an Oracle database storing all their data. They wanted to continue to use that data for these applications. They were deploying a Node.js app and a Java application built from scratch, but using the existing customer data. They had the existing Nexus repo. They were deploying Jenkins to provide the CI. And they were already using GitHub in their organization. In their environment, they had OpenStack and a virtualization provider as well. They were doing a migration over to OpenStack. And so they wanted to be able to run on either environment. And so they were deploying OpenShift, and that provided them Node.js, JBoss, Jenkins, any other language that they really wanted, any Docker image that you want to pull down, you can put in there. And then they had an existing network infrastructure for load balancing. They were using the F5 at this, in this particular case. And so the PaaS actually integrated into the F5 load balancer and allowed them to automatically scale up and scale down. So saving a lot of time. And then also the existing DNS. So that's what the architecture looked like. In terms of what was the ROI in the shift from their traditional development model to a DevOps model, leveraging Docker, Kubernetes, and a PaaS, Well, first off was the improved business agility, because now they reduced the provisioning time from many weeks to under 30 minutes consistently. They were also able to shorten the time to market of their new products as well, and they could do that consistently. Improved developer productivity, right? So they were able to greatly improve the ability through self-service. The developers could get access to whatever they wanted. They were able to do CI/CD for the first time. They also were able to reduce the iteration of bugs by the dev and QA because they could rapidly get access to the environment they needed, the version of that environment, and debug and troubleshoot. And they were able to test multiple versions. Right? They were able to spin up whatever version that application needed. And they had a consistent set of tooling in dev, QA, and production now. Right? They didn't have the operations folks using a particular configuration tool and developers using another one. Improved business predictability, because every 30 minutes they were able to get new code to production. Their business and finance teams could now accurately predict new revenue streams. The marketing team could efficiently forecast when to place ads, because they knew when the launch was and they had a high confidence level of that they would hit that date. And then also in terms of operational and efficiency and cost, because they went from a virtual environment to a container-based environment, they got about 10x greater density and more efficiency out of their infrastructure. And so, what are some metrics to see if this transformation is successful? Right. So first off is deployment frequency. Right. You may want to track that and see how often are you deploying new code into your production environment. Also, change volume. How much or how many lines of code are being deployed maybe per week? And what is the lead time to get from development into production? And what is the failure rate of your site? Of course, you want to be tracking that. The mean time to recover from any issues, hopefully that's going down over time. And then absolutely monitoring service availability and tracking that over time as well. So there's some metrics you may want to keep in mind if you adopt DevOps to see and measure the improvement, the ROI to your organization as well. And so, to summarize, DevOps alone is not just, it's cultural shift, it's tools and process and technology, but also you want to take a look at maybe transforming your application architecture to one of microservices or a native cloud application architecture. And then also your underlying infrastructure to match that, whether it's a dynamic private or public cloud infrastructure, and package your applications in containers, right, to take full advantage of this new process and new architecture of your development team. All right, so I want to thank you for attending today. Happy to answer any questions that you may have. I have my email up there. I'm also on LinkedIn. Feel free to reach out if you don't have a chance to connect today. Thank you very much.